In a previous lesson, you learned the different trig functions. You learned sine, cosine, tangent. You also learned the inverses of those, which would be cosecant, secant, and cotangent. And you learned the different ratios or different measurements for each of those for different common angle measures. Specifically, we learned about 30-degree angle, 45-degree angle, and a 60-degree angle. Now in this lesson, we're going to extend that knowledge to include any angle measure. So not just angles in that first quadrant, we're going to now include angles in the second, third, or fourth quadrant, and also include what we call quadrantal angles, which would fall right at 0 degrees, 90 degrees, 180, or 270. So to expand our knowledge, we need to kind of look at these trig functions from a little different point of view. And what we're going to do is we're going to take a coordinate graph like this. And we're going to create an angle, as we see here. So this angle goes around from 0 all the way to this location. All right, and notice we have a point on the angle. The point we'll call point x, y. And then what we have here, the r value, it's kind of like the radius or hypotenuse in this situation. And what we're going to do is we're going to try to develop or figure out what are our different trig ratios. So sine, cosine, tangent, what are those ratios with this example? So to do that, what's going to happen is we're going to basically drop a line right here to create a 90-degree angle, so that now we have a right triangle over here in the second quadrant. All right, so now what we're going to do is actually look at this angle right here and figure out the sine, cosine, tangent of this angle. All right, so the opposite side of this angle, the height of that segment is the y value. All right, so the y value from the point, that is the length from the x-axis up to that point. And then down here, this length would be x. This is the same x value that is up here with our point. And we know that to be true because that is how far to the left that point is from the origin. And then r would be this segment over here from the origin up to the point up here. So now with that information, if we try to find sine, cosine, and tangent, okay, sine of that angle, sine of theta, is equal to opposite over hypotenuse, which is y over r. And then cosine of that angle is equal to adjacent over hypotenuse, or x over r. And then tangent of that angle, tangent of theta, is equal to opposite over adjacent, which would be y over x. And then we can do the inverses of each of these functions as well. So the inverse of sine would be cosecant. So instead of y over r, we have r over y. The inverse of cosine is secant. So instead of x over r, we have r over x. And the inverse of tangent is cotangent. And instead of y over x, we now have x over y. So now using that information, what we want to do is figure out the 6 trig functions of an angle in standard position whose terminal ray goes through the point 3, -4. Now remember, standard position means that the one angle, or I should say the initial ray, starts at the origin and it goes here to the right on the x-axis. So that would be in standard position. And the ray goes through the point of 3, -4. So 3, -4 would be 3 down 4. It'd be down to this location right here. And we're trying to find the 6 trig functions of this angle. So to do that, it's going to be helpful, again, if you create a right triangle. So we create a right triangle going to there. And now what we have is we have a triangle with this top part with a length of 3. All right, that is the x value, right? And then the this other side down here has a length of 4, but we'll say it's -4 because it's going down in the negative direction. So we'll give that a length of -4. And the hypotenuse over here we can find by using Pythagorean theorem. We would do the 3 squared plus negative 4 squared equals your hypotenuse squared. We'll call r hypotenuse. All right, so then we would have 9 plus 16 equals r squared. R squared is 25, so then r would equal 5. All right, so this length would have a length of 5. So now to find the trig functions, all we do is look at these different side lengths. So using this as our angle, this negative 4 is opposite, 3 would be adjacent, and then 5 is your hypotenuse. All right, so the sine of theta is opposite over hypotenuse, so we have negative 4 over 5. And then cosine of theta is adjacent over hypotenuse, which is 3 over 5. And then tangent is opposite over adjacent, so we have negative 4 over 3. And then we have the inverses of each of these. The inverse of sine is cosecant, so we would do 5 over negative 4. The inverse of cosine is secant, so we just switch the top and the bottom to get 5 over 3. The inverse of tangent is cotangent, so again switch the top and the bottom to get 3 over negative 4. So that is our 6 trig functions of the angle in standard position with the terminal ray going through the point 3, negative 4. And we can use that for any type of point that we have. So if you have a point, you do the same process. You create a right triangle, make sure if it's going in the negative direction, either to the left for x or down for y, then you give it a negative length so that your trig ratios are correct. So the way that we set up our description of sine, cosine, tangent in this lesson using the values of x and y and r is going to be helpful for us as we extend our information to include what we call the quadrantal angles, which would include 0 degrees, 90 degrees, 180, and then 270 degrees. So basically any angle that falls right on one of these axes. So we're going to begin with looking at a 0 degree angle. We'll also include in a moment the other angles as well. And here, the way we have this set up is we have our point right on the x-axis, and that point we'll call x comma 0, because it doesn't matter necessarily what the x value is, but we do know the y value is 0 because any point on the axis would be 0. All right, so what we can do is realize that, as well as the fact that length r right here, that is the same length as x in this situation. So when you find sine, cosine, and tangent, you can keep that in mind. We see that typed up in the notes here, r is equal to x. All right, so we said with our previous definitions of sine, cosine, tangent, that sine of theta can be represented as y over r. So here, y is 0, r is the same thing as x, which doesn't really matter because we have 0 divided by some value, which would equal 0. So the sine of a 0 degree angle is equal to 0. And then cosine would be x over r. All right, remember r and x are the same length. So we're dividing x by x, or x by itself, which would be equal to 1. So the cosine of a 0 degree angle is equal to 1. And then the tangent of the angle is equal to y over x, which would be 0 over x, or just 0. So the answer for the tangent of 0 degrees would be 0. And then we can also find the inverses of each of these, so cosecant, secant, and cotangent, by doing 1 over each of these. So if you did 1 over 0, that would give you cosecant, which is undefined. If we did 1 over 1, that would give you 1, which would be secant. And then if we did 1 over 0, that would be undefined as well. And so the cotangent of 0 degrees would be undefined. So once you have this information right here, you can find these values over here. And by the way, I personally, when I think through this, once I find sine and cosine, tangent, another way we can think of tangent and we'll learn this, I think, in a later lesson, is that tangent is equal to sine over cosine. So if you know that fact as well, you can think through it as 0 divided by 1, which is 0. So that's one other way you could think through that. And this may be getting a little bit ahead of myself, but a lot of this information right here, I actually have a different way of remembering these facts. So instead of thinking through y over r or x over r, personally, the way that I remember sine of 0 or sine of 90 or whatever is realize that if this is a unit circle, meaning that this has a length of 1, so if you imagine drawing a circle with a length of 1 or radius of 1, if we pick any point on here, that point would be the cosine of whatever angle you have. That's your x value, and then sine is your y value. So whenever I see this, if I ever have something where it falls right on the axis, like 0 degrees or 90 or whatever, okay, when I see that, I think through the fact that if it's 0 degrees, for example, okay, the cosine, okay, the x value has a length of 1. It's got a length of 1, right? That's your x value. So the cosine of 0 degrees is equal to 1. It's the length of that x value. Whereas the sine of 0 degrees is the y value. Notice it does not go up at all, right? It's right there on that line. Sine of 0 degrees, therefore, is 0. It's the y component of that ordered pair. So again, that's personally the way I remember this, but this is actually a little more advanced. That's, I think, the next lesson. But either way, make sure you have at least these two memorized, and then you can figure out tangent by remembering sine divided by cosine is equal to tangent. So we took care of 0 degrees, but we also want to talk about 90 degrees, 180, and then 270 as well. So if you're looking at a 90-degree angle, okay, so an angle like this right here, and we're trying to figure out sine, cosine, and tangent. So again, you can go through the thought process that I gave you with the y over r and then y over x. You can do that, or you can use my other method of thinking through this, which I personally prefer, and that is the fact that the sine of 90 degrees, if you're looking here, the y component is sine. So if you're thinking through a unit circle where the circle has a radius of 1, okay, that y component would equal 1. Whereas the cosine of 90 degrees, that would be the x value, the x component, and notice it does not go over left or right at all. There is no x component, so cosine of 90 would be 0. So if you know that information, you can then find everything else, because the tangent of 90 is sine over cosine, which is 1 over 0, or undefined. And then you can find all the other information as well. So we can find cosecant of 90. That would be 1 over sine, which is 1 over 1, or 1. You can find secant of 90, which would be 1 over 0, which is undefined. And then the cotangent of 90, okay, that would be the inverse of this, which, if tangent is sine over cosine, cotangent is the inverse, which would be cosine over sine. That would be 0 over 1, which would be 0. All right, so now we have all this for 90 degrees. Next, we'll do the same thing with 180 degrees, starting here and going over to this side. All right, so 180 degrees, we're going to find all the same information. So if you want to find the sine of 180 degrees, if you use my method to remember this, okay, sine is the y component. And if you think through a unit circle where the radius is going to be 1, okay, the sine, or the y component, would actually be 0. There is no y component here, right? It does not go up or down at all. So sine of 180 is 0. Cosine of 180 is the x component. And with the length of 1, all right, for the unit circle, length of 1, your cosine would be actually negative 1 because it goes in the negative direction 1. So cosine of 180 is negative 1. Then we can find everything else from that. Tangent is sine over cosine, 0 over negative 1, which is 0. And then we can find cosecant. Cosecant of 180 is the inverse of sine, which would be 1 over 0, which is undefined. Then secant is the inverse of cosine. That would be 1 over negative 1, which would be negative 1. And then cotangent of 180, that would be the inverse of tangent, which is 1 over 0, or undefined. So now we have everything we need for all the trig functions for 180 degrees as well. Now let's do this one more time to work with a 270 degree angle. All right, so if you're using my thought process, if you're trying to find the sine of 270 degrees, okay, what we do is look at the y component. So if it's going straight down, okay, and again, we're assuming a unit circle where the length of the radius is 1, it goes straight down, that has a length of negative 1. It's going down in the negative direction 1 unit. The cosine of 270, that's the x value. Notice it does not go left or right at all, so there is no x component, so x, or the cosine, would be 0. And then the tangent of 270, that would be, by definition, sine over cosine, which is negative 1 over 0, or undefined. And then we can also do the inverses. So the inverse of sine would be cosecant. So the cosecant of 270 is going to be 1 over the sine, 1 over negative 1, which is negative 1. And the secant is the inverse of cosine. That would be 1 over 0, or undefined. And then the cotangent of 270, that is the inverse of tangent. Tangent was sine over cosine. Cotangent would be the other way, cosine over sine. So we have 0 over negative 1, which would equal 0. So you could try to memorize all of this, but it's really not necessary. So if the way I personally do this is what I just showed you right here. I just figure out sine and cosine with that logic that I used, and then from there I can find all the other trig ratios. Now let's talk about the signs of different trig functions when they fall within different quadrants. So here we have a table we're going to go through, and we have our trig functions of sine and cosecant. Those go together because they're inverses. Cosine and secant, those go together because those are inverses. And then tangent and cotangent, which are also inverses. And what we want to do is figure out the sign of each of these in the 4 different quadrants. All right, so if you look at your coordinate plane like this, and if you remember the fact that I said that sine is the equivalent of the y value, so think y when you think sine, and then when you think cosine, think the x value. All right, so if you're looking up here in quadrant 1, up here in the top right corner, quadrant 1, sine, or the y value, would be positive. So sine, along with cosecant, would be positive up in that first quadrant. And then cosine is the x value. So up in the first quadrant, x would be positive because x is positive when it's to the right. Okay, so in the first quadrant, cosine, which means secant as well, are both positive. And then if you remember the fact that tangent, by definition, can be thought of as sine divided by cosine. If you remember that fact, tangent equals sine over cosine, then you realize if you have 2 positive numbers divided by each other, then tangent as well as cotangent would both be positive. Now what about quadrant 2, which would be up here in the top left corner? So quadrant 2 is up here. If you, again, think of sine as your y value, well, if you're in quadrant 2, y is positive, right? If it's above the x-axis, it's positive. So y, the sine, and cosecant, the inverse, would be positive. And then cosine, the x component, the x value, that is negative when it's over here to the left. So cosine as well as the inverse would both be negative. And then tangent, if you think of that as sine over cosine, you have a positive number divided by a negative number. That means you would have a negative number for tangent as well as cotangent. Now what about quadrant 3? Well, down here, both x and y are negative. So sine and cosine both are negative, as well as their inverses. And then tangent, if you divide two negative numbers for sine and cosine, two negatives divided by each other makes a positive number. So the tangent and the inverse, cotangent, are both positive. And now to finish off with quadrant 4, in quadrant 4, y is negative, and x is positive. So y is down below, that's negative. That makes sine negative, as well as the inverse. And then cosine is positive, because x is positive. And then tangent is sine over cosine. If you divide a negative by a positive number, that means that you have a negative answer. So the tangent as well as the cotangent would both be negative. So now, using that information, let's try to figure out this problem. If you're told to find the other 6 trig functions if the sine of theta is equal to 4/5 and theta is between 90 and 270 degrees, how would we set this up? Well, if you think through this, okay, 90 and 270 degrees, here is 90, down here is 270, so it's got to be within this region over here in the second or third quadrant. But it says that sine is positive 4/5. Because it is a positive number, that means it must be up here in quadrant 2. Because if it's in quadrant 3, sine would have to be negative because it's below the x-axis. So we know that sine must be there in quadrant 2. So what we can do is create a right triangle like this, where we have an angle right here, okay, some unknown angle, and if sine is 4/5, that means opposite, okay, remember opposite over hypotenuse, that means the opposite side has a length of 4, which would be right here, and the hypotenuse has a length of 5, which is right here. Now if that's the case, we can find this missing side length down here to find the other trig functions. And you can recognize this as a 3, 4, 5 triangle. You could use Pythagorean theorem to find that to be 3, or just remember the fact that we have this as a special triangle. And by the way, this side down here does have a length of 3, but because it is going in the negative direction, we need to write that as a negative 3. So now what we can do is find the other trig functions, and it shouldn't say find the other trig 6 functions, it should be the other 5 trig functions. But either way, we have sine already. Cosine of that angle would be adjacent over hypotenuse. So this is opposite, hypotenuse, this would be adjacent. So adjacent over hypotenuse would be negative 3/5. And then the tangent of theta is equal to opposite over adjacent, which would be 4/-3. And the sine was already given to us as 4/5. Now we can do the inverse of each of these. The inverse of cosine is secant. So the secant of theta would be the inverse. So instead of negative 3/5, we have 5/-3. The inverse of tangent is cotangent, which would be switching the top and the bottom to get negative 3/4. And the inverse of sine is cosecant. We switch the top and the bottom to get 5/4. So now we have the other trig functions from the sine of theta equaling 4/5. Now, using what we just talked about with the different signs of sine, cosine, and tangent in the different quadrants, what we can do now is we can now put everything together where we can take what we know about the 30-degree angle, 45-degree angle, and the 60-degree angle. We can take that information that we know about quadrant 1, and we can extrapolate all the other angle measures in the other quadrants. And I guess I shouldn't say all the angle measures, but all the multiples of 30 degrees, 60 degrees, or 45 degrees. All right, so what we need to do is understand this idea of what is called a reference angle. So by definition, it is the acute angle formed from the terminal ray and the x-axis. So here in quadrant 1, it's very simple because your reference angle would be this angle right here between the terminal angle, which is this one, the terminal angle, and the x-axis. And we can call that angle theta. So Greek letter theta, like that. Now if we look in the second quadrant, here we have our angle, where the terminal ray is this ray right here, and it's in the second quadrant. So our reference angle is the angle formed between that ray and the x-axis, which is right down here. So that angle right there, we'll call it angle theta. That is our reference angle. And then down here in the third quadrant, we see our terminal angle, terminal ray is right here. And our reference angle is created by finding the angle between that ray and the x-axis, which would be right here. So that angle would be called your reference angle. And then over here in the fourth quadrant, here our terminal angle, terminal ray, is here in the fourth quadrant, and our reference angle is the angle between that terminal ray and the x-axis, which would be right here. And that would be your terminal or reference angle. So let's practice a couple where we are to find the measure of the reference angle. So for this one, if you're given angle equaling 135 degrees, what is the measure of the reference angle? So 135 degrees would be over here in quadrant 2, is between 90 and 180. And the reference angle would be this angle right in here. So what we can do is we can subtract 180 degrees by 135 to figure out what angle would be right here. Because 135 plus this angle, whatever that is, must equal 180 to create the line. And so the angle that would add to be 180 would be 45. So this angle measure, the reference angle, is 45 degrees. And by the way, the notation here, theta would be the original angle, it's 135. Theta prime, we'll call that the reference angle, because the prime indicates that it's related to the original angle, but it's not the same angle. Let's try another one. Here we have theta equaling 300 degrees. Now this one would be down here in quadrant 4. We go around 300 degrees. That takes us past the 270 mark. It's between 270 and 360. We get this angle right here. Now the reference angle is the angle between that terminal ray and the x-axis right here. So our objective is to figure out what is the measure of that angle. Well, we know that we went 300 degrees to get to this ray right here. If we add whatever this measure is here in this location, that would equal a total of 360 degrees to get you all the way back to the beginning. So 300 plus what is 360? That would be 60 degrees. Another way of thinking of that is by doing 360 minus the angle measure of 300. So the reference angle would be 60 degrees. Now let's try two examples dealing with radian measure. So instead of angle or degree measure, we're going to work with radians. And here we have our angle equaling 9 pi over 4. So where would that be located? Well, think through the fact that 9 pi over 4, that is greater than 1 revolution around the circle, because 2 pi is 1 revolution. And 2 pi, if you write as something over 4, would be 8 pi over 4. This is 9 pi over 4, meaning it's going beyond 1 revolution. And how far past 1 revolution is it? Well, we subtract 9 pi over 4, subtract that by 8 pi over 4. That gives you your coterminal angle, which would be pi over 4, 1 pi over 4. So your reference angle would be right up in here, and that would be pi over 4. And it's in the first quadrant, so it just is what it is. All right, so the reference angle is pi over 4. Let's try another example. Here we have theta equals 4 pi over 3. All right, so when you think through this one, okay, realize that 3 pi over 3, that's equal to 1 pi, right? 1 pi is half of a revolution because all the way around is 2 pi. So as 1 pi is right there, so then we need to add another third to get to 4/3 pi. So if we add another third of a pi, that takes you down to here to be 4 pi over 3. All right, so this reference angle right here, that's 1/3 pi past halfway around the circle. So that reference angle would simply be pi over 3, because that would be how much further past pi that angle is. So again, the reference angle for that one is pi over 3, this angle right in here. So now putting everything together with the different signs, whether positive or negative, of sine, cosine, and tangent, as well as using reference angles, what we want to do now is to use reference angles to find a trigonometric function of any angle using the reference angle. So to do this, okay, you want to do step 1, which is find the reference angle, and then step 2 is you want to determine the sign of the trig function for that angle, and then the value of the trig function for that angle, it will be equal to the value of the trig function for the reference angle, except make sure you have the proper sign. All right, let's put that together and see how that works. All right, here we have our first example using reference angles, where we're trying to find the sine of 120 degrees. So to do this, you want to find your reference angle to begin. All right, so sine of 120. 120 degrees would be right up in here. Okay, that would be the angle. And we're trying to find the reference angle, which would be right here. Okay, so to do that, you would take 180 degrees minus the 120 that we have over here, and that leaves you with 60 degrees. So that reference angle is 60 degrees. And we realize that because it's in quadrant 2, that sine is going to be positive. Sine is positive up in quadrant 2. So what we do now to finish off is we find the sine of 60 degrees. Whatever that is, make sure then you take that answer and make it positive. And we've memorized in the past that the sine of 60 degrees is the square root of 3 over 2. So you make sure it's positive, which it already is, so that would be your the sine of 120 degrees. So as you can see from this example, that it's going to be crucial to have memorized your basic trig facts, so like sine, cosine, and tangent of a 30-degree angle, a 45-degree angle, and a 60-degree angle, because you need that information to find now the sine, cosine, and tangent of all these other angles as well. For our second example here, we're trying to find the cosine of 225 degrees. All right, so first off, you want to find your reference angle. 225 degrees, that would be over in this area, right? It's going to be past 180. It's going to be down here, and that gives you 225 degrees. And now our objective is to find, first of all, the reference angle, which is this angle right here between the terminal ray and the x-axis. Well, how far past 180 is that angle? Well, if we subtract 225 minus 180, that gives you 45 degrees. So this reference angle down here is 45 degrees. And then we can figure out the sine. So cosine of 225 degrees. Cosine down here in the third quadrant is going to be negative, because x is negative in that direction. So what we do is, instead of finding cosine of 225, we find the cosine of 45 degrees and then make it negative. Well, the cosine of 45 degrees is the square root of 2 over 2. Make it negative. So now the cosine is negative square root of 2 over 2. Let's try one more example. Here we have tangent of 11 pi over 6. All right, so to begin with, we want to figure out our reference angle. All right, so 11 pi over 6. Different ways you can think through this as to where that angle is going to be. Personally, the way that I would think through this is that it's very close to 2 pi. 2 pi, all the way around 1 revolution, if you write that as something over 6, would be 12 pi over 6. This is only 1 pi over 6 away from that. So what I can do is realize that the angle is going to be really close to 1 complete revolution, but it's going to be 1 pi over 6 short, which would also give us our reference angle to be pi over 6, 1 pi over 6. So the reference angle is pi over 6. And now we need to figure out with tangent, is tangent going to be positive or negative down in the fourth quadrant? Well, remember that tangent is the same thing as sine over cosine. Down in the fourth quadrant, okay, sine is negative because y is negative, and then cosine is positive because x is positive. So negative divided by positive would give you a negative answer. So tangent down in the fourth quadrant must be negative. So what we do is, instead of finding the tangent of 11 pi over 6, we find the tangent of pi over 6 and then make it negative. So to do that, different ways you could process that, but I like to break it up. So I have sine of pi over 6 first, and sine of pi over 6 is 1 over 2, and then cosine of pi over 6 is the square root of 3 over 2. And then tangent would be sine over cosine, meaning we do 1/2 divide by, so divide by the square root of 3 over 2, which means we're multiplying by the reciprocal, 2 over the square root of 3, which means 2's would cancel. You're left with 1 over the square root of 3, which can rationalize, and you would get the square root of 3 over 3. I'm running out of room, put it over here. And then just make it negative. So our answer would be negative square root of 3 over 3. So that is how you can use reference angles to find sine, cosine, and tangent, as well as the inverses of any, basically any angle that we're given, assuming that the angle is a multiple of 30 degrees, 45 degrees, or 60 degrees. And that concludes our lesson for today. We will see you next time.